Today we're going to take a look at section 1.9, scientific notation. So the program that I use to create your homeworks and all of that kind of stuff has scientific notation located in another kind of a module. So you'll notice that the tops of like the printouts might look a little bit different than some of them, and they're slightly different on the top than they've looked in the past. And that's true when we get to the quizzes and the exams for this particular section of material as well, just because I had to go to a different module to pull from to be able to print them. So scientific notation has a basic form that looks like a times 10 to the n, where the a value is between 1 and 10. It can equal 1. It should not equal 10. Does your book say that right, or does it actually have the equal sign under the 10? Nobody's talking to me. It does. Okay, that's a typo. So scribble the part out that says less than or equal to 10. It should just say less than. I'll get that fixed in the notes later. Right here, it should say less than, not less than or equal in your notes. My apologies. The number cannot be a 2-digit number. It can only be in the ones place. So a is between 1 and 10, and n is an integer. Now, we've talked about integers. Okay, so positive and negative whole numbers. That's what n can be. So the exponent can't be fractions, it can't be decimals, it can't be radicals or pi or anything like that, but it could be negative 72, or it could be positive 356, or it could be 0, right? We're going to look both at going between scientific and standard and scientific notation. So the first one we're going to look at is actually taking a standard number and turning it into scientific notation. So as we're working with a standard numeral and turning it into scientific, we're going to move the decimal point until we create a number between 1 and 10. We're going to count how many places that decimal moved. And then the way that I describe this is a little bit different than you might have heard in the past. I think it can be very confusing to decide, do I go to the left or to the right? Because it depends on whether you're going from scientific to standard or standard to scientific, which you do. So instead, what you can actually consider and think about is what the exponent means. A positive exponent means you have a big number. And big means bigger than 10. And a negative exponent means you have a small number, and small means smaller than 1. So if you started out with a number that was big, your exponent will be a positive digit. And if you started out with something that was small, your exponent will be negative. So here's a couple of examples of that. The first thing we have to decide, according to the process defined before, is where I need to put the decimal point so that I can create a number out of these digits that's between 1 and 10. So where will my decimal point need to land? 2.9. Yeah, right here is where my decimal point needs to be, right? So as I rewrite this, I'm going to have a 2. I'm going to have a decimal point and a 9/8. All the zeros after that do not need to be written. They're not holding any place value of consequence for us. And then what we need to do is we need to figure out how many places our decimal moved. Now, you might look at that and say, but Dr. Hens, there's no decimal. And while that's true visually, technically that means the decimal's here. Like that's where it would fall if we were actually going to have something after it. That would be it. So this is where we're going to start to count from. So we can count 1, 2, 3, 4, and 5. The decimal moved 5 places. Okay, just counting. So this is 2.98 times 10 to the 5th. We just need to decide if the 5 is a positive or negative. So the original number, was it big or small? It was big. So is my exponent positive or negative? It's positive. Positive exponent, large number. Okay, same idea for the next one. I have this decimal expression. Where would I need my decimal place to be in order to create a numeral that's between 1 and 10? Between the 3 and the 8, right there. So 3.8 is going to be my A value. And I actually see the decimal this time, right? So I can count how many moves I make. 1, 2, 3, 4. So it's times 10 to the 4th. Is the decimal that I started with, the original value, is it small or big? Small. So my exponent will be negative. Okay? Big numbers, positive exponents, small numbers, negative exponents. So that's how we move from standard notation into scientific notation. We're going to reverse the process now and go from standard notation into, from scientific notation into standard. So in this case, we're going to start out with a number that has a time 10 to a power. And we're going to move our decimal point the number of places indicated by the exponent. Now, whether we make the number a small number or a big number depends on whether the exponent is positive or negative. If the exponent is positive, the number will become big. If the exponent is negative, the number will become small. So, these are our digits. The exponent tells us how many places we're going to move our decimal. In this case, on the first one, it's 5. I'm going to move it 5. But do I want my number to become bigger or smaller? Smaller, right? Because it's negative. So if in order to create the number making it smaller, will it go to the left or will it go to the right? It'll go to the left. So whatever it takes visually for you to do that, you can put just a bunch of zeros down until you know how many you need. And you're going to move that 4 places. 1, 2, 3, and 4. So you need a decimal point, 3 zeros, and then a 3, 2. If you want to put a 0 in front of that, you can. If you don't put it, you don't have to. It doesn't make any difference. It's completely irrelevant whether that 0 there is there or not. This would be your value as a standard numeral.
Wait, why 4 and not 5?
Oh, it was 5. I apologize. I was thinking about my last problem, which was 4. I apologize. It was 5. We'll fix it. Thank you for catching that, Walker.
That threw me off.
So sorry. I didn't mean to throw you off. I was stuck on my last one, which had an exponent of 4. It is 5 places. Thank you. 5 places. All right, how about my next one? How many places am I going to move my decimal? 3. Will my number get bigger or smaller? Bigger. Why? Because the exponent's positive. So which direction would my decimal have to move to make the number bigger? To the right. So I have my number right now, which is 6.24. You can put some zeros in, as many as you want to for now. Move it 1, 2, and 3, which is exactly what it was supposed to do this time. And so my number needs to be 6, 2, 4, 0. And those extra zeros I threw on the end are not necessary.
We don't need to put our decimal.
You don't have to. If you do, it's not wrong, but you don't need to if it's a whole number anyway. Yep. Okay, so why does scientific notation matter? Where do you see it used? What kinds of values do you see it used for? In chemistry. So what kind of things in chemistry are you using scientific notation for? Conversions. Ooh, atomic. What does atomic mean? Things that are very small or very big. It depends on what you're measuring, right? So if you're measuring things that are very, very small, that's where you usually see it in chemistry. Or things that are very, very large. We sometimes see that in physics. So those are where we see scientific notation come into play. You do not measure your bank accounts in scientific notation. And the reason you don't is because it doesn't make any sense. There's no need. Right? Scientific notation is used for very, very large or very, very small numbers. Now, in particular, we're going to do some examples of how we can do operations with scientific notation. In particular, multiplication and division. It is not helpful to turn them all into standard and then just to do your division. You do not want to do that. All right? Leaving it in scientific notation to perform your operations is far, far easier. So let me show you an example. I have 8 times 10 to the 12th and 6 times 10 to the 15th. What you see here is 4 numbers all multiplied. Correct? It is. And one of our properties that we discussed a couple class periods ago about multiplication is something called commutative and associative. Commutative and associative allow me, when I'm working with all multiplication, which this is, to reorganize it in a way that's more helpful. So I can reorganize this so that I would group the 8 times the 6 together, and the 10 to the 12th, and the 10 to the 15th together. Does that make sense? It's kind of like grouping like terms, not necessarily because we're grouping like terms, but we're putting things together that combine nicely. What's 8 times 6? 48. And what is 10 to the 12th times 10 to the 15th? Say it louder, Harrison. 10 to the 27th. You're right. So this is where our last section of material comes in and why the section comes right here in our notes. That's what we're doing. We are multiplying this now by 10 to the 27th. And somebody tell me how did we get 27 on that? Yeah, you add the exponents together, right?
Do we not have to multiply the whole numbers?
We did multiply the whole numbers, 8 and 6.
I meant like 10, the tens.
Okay, so this is like having a to the, what were my numbers, 12 and 15? A to the 12th and a to the 15th. We are multiplying them, okay? So the 10 is really listed 12 times, and then the 10 is listed 15 times.
Oh, okay, got it.
So really, notations with exponents is just condensed notation. So we are, in fact, multiplying them, but they don't change because I'm not going to write them all out, okay? I'm not done, though. How am I supposed to give my answer? Scientific notation, and what's wrong with the answer that I currently have?
It's not counted.
What's failing to be in scientific notation? What was it? A decimal point.
Wait a minute. You have to multiply 20, you said there's 27 zeros.
No? So Allie's on the close. You're really close, Allie. It has to do with a decimal point.
Oh, you have to put it in between the 4 and the 8.
Yeah, so scientific notation has a number at the beginning that's between what?
1 and 10.
1 and 10. And is 48 satisfy that? No, it does not. In fact, you're exactly right, like Allie was saying, it's missing that decimal point, but the reason that it is because 48 is not between 1 and 10. So I need to adjust this slightly. The adjustment's pretty simple. Obviously, the adjustment is that it's supposed to be 4.8. But I can't just change 48 into 4.8 and leave the rest the same, right? I mean, I can't just do that. There's got to be some compensation for the fact that I changed 48 into 4.8. And so the compensation, in fact, is that I took a number that was big, right? I adjusted it, so my compensation is in the exponent. My exponent needs to become bigger, 1 bigger. 28. Okay, this is a big number, so I'm going to add a positive 1. It's 27 plus my 1, that's 28. And the reason it's 1 is because I moved my decimal place 1 place. The decimal point,
Move your decimal, but you have to go up.
yes. The decimal point is right here, and I moved it 1, so the decimal actually moved 1 location. So I added value of 1 to my exponent. 1 move. Okay, we can do the same thing on number 6. You can grab a calculator if you'd like. I have the 1.2, and I'm going to put parentheses because there's a lot of dots and things going on. A 9.5. And then I have 10 to the negative 2 and 10 to the 12th. So what is 1.2 times 9.5?
11.4.
Thank you. 11.4. 10 to what power?
The
10
10.
to the 10th. So just like on the last one, I add my exponents. It just happens to be that one of my exponents is negative. Negative 2, positive 12 is 10.
It's not 2 more to 10.
You're right, it's not. So I need my decimal point to be here instead. So I need it to be 1.14. Now, while it's not super big, 11 is still considered a big number. By the way, we're describing it because it's bigger than 10. So my exponent needs to become 10 to the 11th. It needs to become 1 bigger because the number was big to start with. So the exponent will become 1 bigger.
If it is in between 1 and 10, we just leave it how it is.
You bet.
Does
Mhm.
the exponent ever become smaller?
Yes, we're about to do one. It's a good question. At least I think we are. If we're not, I'll make another one up. I can't remember if either of these two do that, but I wanted them to. Okay, you can do a division as well. Yeah, these aren't going to do it, but I'll make one up for you, Cameron. All right, so you could do this process with division the same way. Okay? I have multiplication on the top, I have multiplication on the bottom, the division sign in between them, but I can still do the same kind of grouping in a very real way. I can think of this as 8 divided by 2 times 10 to the 4th divided by 10 to the negative 6th. Okay? So you don't have to necessarily write that out, but that's how I can think about it. What is 8 divided by 2? That's 4. And then what am I going to have to do with those exponents?
Subtract.
I'm going to have to subtract. So this is 10 to the 4 minus negative 6. Not 4 minus 6, 4 minus negative 6. Positive 10 is it? Yes. 10 to the 10th. The next one, I won't write it this time. We'll just think about it that way. I have 9 divided by 2. What's that? 4.5 is right. And then when I consider my powers of 10, what do I get? Yeah. 8 on top, 3 on bottom. I subtract and I get 5. So let me make one more up. I did not get one in there that I wanted. We'll go with that. It's negative 7 on top, negative 8 on bottom. So again, looking at the 2 times 2 divided by 5. What's 2 divided by 5?
0.4.
Yep, it is. And then my exponents are negative 7 minus negative 8, right? So there's a couple things I need to do. First, let's deal with the negative 7 minus negative 8. That becomes addition. Negative 7 and positive 8 would be 1. So I have 0.4 times 10 to the 1. I'm going to leave it actually written as 10 to the 1 for now especially. This 0.4, though, is not between 1 and 10, right? So I have to move my decimal. And in particular, I need to move my decimal this time to make the number actually become bigger, right? It's a small number to start with. So my 4.4 becomes 4. And then my exponent in this time actually has to become smaller, right? And it's 1 smaller than it already is, and it's at a 1 already, so it actually will become a 0. Yeah, if we subtract 1 away from 1, I get 0. This is the scientific notation it would end up in. So you can have exponents that are 0. It's totally fine. You know what it is. What's 10 to the 0? 1. This is just the grandiose number 4, actually. I made it up. I didn't really mean for it to do that per se, but I wanted you to see what happens when you get a decimal. Any questions on that? All right.